In this video, we're going to solve quadratic equations by factoring. To solve a quadratic equation by factoring, we can follow this strategy. We'll write the equation in standard form so that one side of the equation is equal to 0. The other side of the equation should be written from highest to lowest power. We'll factor the polynomial completely, and we do have a variety of different factoring techniques that might need to be used. We'll set each factor containing a variable equal to 0. This is called the zero factor property. Then we can solve the resulting equations. It's a good idea to check each solution in the original equation. Our first example is 3x squared minus 15x equals 0. So notice this is very similar to the trinomials and other polynomials that we were factoring, but now we have equations. So we've definitely got the equal sign here. To be in standard form, one side of the equation must be equal to 0, and the other side of the equation should be written from highest to lowest power. So we have x squared and x to the first. That looks like it's in the right order. Since we only have two terms, we need to think of what type of factoring have we done with two terms. It might be a difference of squares or just greatest common factor. 3 and 15 are not perfect squares, so we know that it cannot be a difference of squares. So we'll look at greatest common factor. 3 and 15 have a common factor of 3. X squared and x both have at least x in common. So 3x is our greatest common factor, and then using the distributive property, we would have a quantity of x minus 5. Checking, 3x times x matches 3x squared, and 3x times negative 5 matches negative 15x. Also, you can see that the original was an equation equal to 0, so we must keep that. So now we have our zero factor property to use. Each factor is going to be set equal to 0. So 3x equals 0 and x minus 5 will be set to 0. In order to solve for x in our first equation, I'll need to divide each side of the equation by 3. And that leaves x equals 0. So don't leave 0 thirds. That does simplify as 0. So one solution is 0. X minus 5 is set to 0. So by adding 5 using the addition property of equality, I end up with x equals positive 5 for the other solution. Typically, if you start with the second degree equation, that should result in two solutions. So it is a good idea to check these answers. I'll start with 0. So substituting 0 for x, I would have the equation 3 times 0 squared minus 15 times 0 equals 0. So this makes 3 times 0 minus 0 equals 0. And again, 0 minus 0 equals 0. Sure enough, this is true. 0 does equal 0. So that means we would keep the solution x equals 0. For the other check, we're going to let x equal 5. 3 times the quantity of 5 squared minus 15 times 5 is set equal to 0. That means 3 times 25 minus 75 equals 0. 3 times 25 is 75 minus 75 equals 0. So again, we end up with a true statement. That means the solution of x equals 5 is indeed a solution. So both answers are correct. In example 2, we have 8x squared plus 13x plus 5. So it is a trinomial. The first and the last terms are not perfect squares, so it's nothing quick and easy here. Do 8, 13, and 5 have a common factor? No. So it looks like we have to use our sum and product technique. In the middle, positive 13 tells us the sum we're trying to match, and then 8 times 5 would be positive 40 for the product to match. So with 40, since it ends with 0, you might be thinking of 4 times 10. But 4 plus 10 makes 14. That won't work. Let's try something else. Let's see. If it ends with 0, it's divisible by 5. 5 times 8 makes 40. 5 plus 8, that does match 13. So we know that the middle term is going to be replaced with 5x and 8x, and both are positive. So we'll have 8x squared plus 5x plus 8x plus 5 equals 0. Since we have 4 terms, we're using grouping, which really is just greatest common factor. So with our first group, it looks like x is the common factor. That leaves 8x plus 5. So remember, leave a gap, and your other quantity should be an exact match for that first quantity. Also, I'm continuing to write equals 0 because this is now an equation. What would we need to multiply 8x by to match this first term of 8x? Since they match exactly, positive 1 is needed. So our common factor becomes 8x plus 5, and the other factor joins x and positive 1, x plus 1. So we have factoring on the left equal to 0 on the right. The zero factor property tells us to take each of these factors and set the factor equal to 0. In order to solve these new linear equations now, we use our properties of equality. So I'll subtract 5 to get 8x equals negative 5. Dividing by 8, I have my first x value as negative 5/8. And sometimes we do have fractions for the answer, and we also will have negative numbers for the answer, so that's okay. For the other linear equation we created, x plus 1 equals 0. We'll subtract 1 from each side, so x equals negative 1. That's our other solution. So we did start out with a quadratic equation, 8x squared, and we do have 2 solutions. So in example 3, you can see that we do not have an equation in standard form. To get this equal to 0, I will subtract 12x from each side of the equation so that we have 0 remaining on the right side. But on the left side, we've got these 3 terms that we need to put in the proper order. Highest power would be x squared, then minus 12x, last plus 32. And that's what is equal to 0. So we look at the terms. It does not appear to have a greatest common factor. The first and last terms are not perfect squares, so that means we're going to sum and product. In the middle, negative 12 tells us the sum. The product comes from the lead coefficient multiplied by the constant term. So that's really 1 times 32, which is 32. Now 32 has several factors. It doesn't matter what you start with as long as you can end up with something having a sum of negative 12. So with 32, I always think of 8 times 4 first. 8 plus 4 for the sum makes positive 12, but our sum is negative. Can you see what needs to be done to the factors of 8 and 4 to fix this? All we have to do is make both 8 and 4 negative numbers. 2 negative numbers will still have the positive product, but negative 8 added to a negative 4 will now match the negative 12 sum that's required. So we are replacing the middle term with minus 8x and minus 4x. Now we have x squared minus 8x minus 4x plus 32 equals 0. And with our 4 terms, we are ready to group. It looks like only x is in common for the first group, leaving x minus 8. So x minus 8 should be the common factor in that quantity. X multiplied by something in this gap needs to match negative 4x. So you can see we have the x, we just need the minus 4. Minus 4 fills that gap. Is negative 8 times negative 4 a match for 32? That looks great. So we matched our common factor, which is x minus 8. We form a new factor with x minus 4, and it is still equal to 0. So I do have an equation with every step. Zero factor property tells us to set each of our factors equal to 0 and then solve. By adding 8, I can see one solution is x equals positive 8. By adding 4, I can see the other solution, x equals positive 4. In example 4, we have 25x squared minus 40x plus 16 equals 0. So it looks great that it's already set to 0. We have our highest to lowest power. So our equation is in the standard form. With the coefficients 25, 40, and 16, it does not look like they have a common factor. X is not in every term, so there's no common factor that's a variable either. The only other thing I would try before going directly to sum and product would be to look at the first and the last term and see if those are perfect squares. Well, it looks like they are. 5 times 5 would give us the 25. Of course, x times x is a perfect square. And 16 is 4 times 4. So this could be a perfect square trinomial. That will factor as one of our special factors. Thinking of square root, 25x squared would be a first term of 5x in each binomial. 16 would be a 4 to fill in the last term. Since the middle term is negative, each of these binomials will need a minus sign. Now we do need to check to make sure that this inside and outside product really make negative 40x. So this inside product is negative 20x. The outside product is also negative 20x. So you can see that makes a total of negative 40x. So it really is a perfect square trinomial. So we're going to set each of our factors equal to 0. Now what do you notice about these factors? Do you see how they are identical? So there's no need to set this up twice. Just take 5x minus 4 and set it to 0 and solve it one time. Adding 4 to both sides, I get 5x equals 4. Division of 5 gives me an x value equal to positive 4/5. Now you may recall that I said earlier that when the lead term has a power of 2, we expect 2 solutions. Well, we actually have 2 solutions. They're just 2 identical solutions. So we only need to write it one time. X equals positive 4/5. In our final example, number 5, we have 3x squared minus 3x minus 36 equals 0. So usually greatest common factor is the first thing that I'm looking for. 3, 3, 36. All of those are divisible by 3. So I know that the greatest common factor involves 3. Only the first 2 terms have x, so we cannot use that variable as part of the greatest common factor. So 3 is the best we can do here. And we'll fill in the terms in the quantity. Since I have 3 terms originally, Remember, you must fill in 3 terms in the quantity. 3 multiplied by x squared would match that first term. 3 multiplied by negative x would match the middle term. And 3 multiplied by negative 12 would match our final term. Now, since we did factor already using 3, it might be completely factored. But since we have a trinomial, it's a good idea to check to make sure if it can factor again. So with negative x, remember that's negative 1x. So negative 1 is our sum, and 1 times negative 12 would be the product. Now you might be thinking of 2 times 6 for 12. One of those factors needs to be negative. If our sum is negative, the larger number or larger factor is negative. But that makes 2 added to negative 6. That's negative 4. That doesn't work. So we need to try some other factors of 12. Maybe 3 times 4. Again, our larger factor needs to be the negative number in order for the sum to be negative. 3 added to negative 4 does make negative 1. So we found the replacement for the middle term. Keeping our original common factor of 3, we now have x squared plus 3x minus 4x minus 12 equals 0. So we have grouping in this quantity. The common factor with x squared and 3x would be x. That leaves x plus 3. So we know x plus 3 must be needed in that other quantity. And there are a lot of parenthesis sets here, so be careful that you have enough sets of parentheses. To create the term in this gap, x needs to be multiplied by something to match negative 4x. So we need negative 4. 3 was the original common factor. Quantity of x plus 3 is the new common factor. And then x and minus 4 make that other factor. Now that the polynomial is completely factored, we can set each factor equal to 0. That's the zero factor property. First, we'll take 3, set that equal to 0. But you can see that since there is no variable with that factor, 3 is not going to equal 0, and therefore we don't end up with a solution being generated from that factor. Next, we have x plus 3. So when I set x plus 3 equal to 0, I would subtract 3 from each side to get an x value equal to negative 3. So there's one of our solutions. The next factor is x minus 4. So when x minus 4 is set to 0, we'll need to add 4 to both sides of the equation. And now we have an x value equal to positive 4. So negative 3 and positive 4 are the two solutions for this equation.